Previously went over the binomial theorem, which helps us expand binomials when they're raised to a certain power. The purpose of that, at least for this course, is kind of to lead us into this, binomial probability. So an example, just to give you an idea where this would apply. Let's say you were rolling a die 10 times, and you wanted to know what the probability was that you would get exactly 4 fours. So you wanted to get 4 fours out of your 10 rolls, and you wanted to know what the probability of that would be. You could use that in this case. So the formula here is n above r. Remember, you can do that in your calculator using that NCR button, times q, which is the probability of failure, raised to the n minus r, times p, which is the probability of success, raised to the r. So just let's talk about these variables one more time. N is the number of trials, or the number of times something happens. So in my example with the die, N would be 10 because you rolled the die 10 times. R is the number of successes you're shooting for. So in this case, if we wanted 4 fours, then we're shooting for 4 successes, and so R would be 4. Now, just to be clear, success doesn't need to mean success in the sense we normally talk about it. Success just means it's what we're aiming for or what we're wanting to happen. So in this case, our success is 4. Now, the P is the probability of success, and then Q is the probability of failure. And if you think about it, Q would just be equal to 1 minus P. So, for example, if there's a 30% chance of success, then there's a 70% chance of failure. If there's a 50% chance of success, there's a 50% chance of failure, and so on. So that's how we get this. Now, I just wrote an example right up here that I want to do here so we can see the equation easily. So this one is similar to what I said earlier. It says, what is the probability of rolling a 4 exactly 25 times if you roll a die 100 times? So our total number of times we're rolling the die is 100. So that will be our n. We're shooting for 25 successes because we want 25 r's, 25 fours. So 25 is our r. So that gives us our r and our n. Now we need to figure out our probabilities. Okay, the probability of success. Well, if you've got a 6-sided die, then your probability of rolling a 4 is 1 in 6. Because you've got 1, 2, 3, 4, 5, 6, so your probability of rolling a 4 is 1 out of 6. So your probability of failure would be 5 out of 6. Because there are 5 numbers that aren't 4, and if you don't roll a 4, then it's not what you want. Okay, so now we can set up the equation. When we set this up, we do n above r, so that will be 100 above 25. And then we put the probability of failure first, and the probability of success second. Now the reason I do it that way, some books write this differently, but I wrote it this way so we can keep the pattern we had before, where whatever this number is also going to correspond to b, or the second number's exponent. And it's still true that the two exponents should add up to n, which in this case is 100. So I knew that whatever plus 25 gave me 100 had to be the answer. Okay, so that would be your setup, and hopefully you can see the pattern there and how it's related to the binomial theorem. So let me pull up the calculator and we'll try this out. So 100, we go to math, probability, go down to 3, and then we do 25. So that gives us a rather large number. It's 2.4 times 10 to the 23rd, so it's a huge number. But you'll see it becomes much smaller once we multiply by these other things. So we multiply that number by 5 over 6 raised to the 75th times 1 over 6 raised to the 25th. Let me make sure I typed all that in correctly. Okay, that looks good. So let's hit enter, and we see we've got a probability of 0.0098. Now remember, this is the decimal form. If we want the percentage form, we have to move it over 2 decimal places. So it's just under a 1% chance. It's a 0.98% chance of success. I will accept either the percentage or the decimal answer. Both are fine. So you see that the probability of rolling 4 exactly 25 times if you roll a die 100 times is a 0.98%. So that's not 98%, that's 0.98, so it's a little less than 1%. Okay, let's try another one. It says a test contains 10 questions with 5 choices each. So you're talking about a multiple choice test with choices A, B, C, D, E. What is the probability of guessing exactly 7 answers correctly? So we're assuming we're just guessing out of the blue. We have no clue what's going on. Certainly that would never actually happen on a test, of course, especially not in my class. But if you're just guessing randomly, what would be the odds of guessing 7 correctly? So basically, what's the odds of passing? Well, passing with exactly a 70. Okay, so our number of trials will be the 10, because that's the number of questions we have. The number of successes we're going for is 7, so that will be our R. And then since there are 5 choices, our probability of success would be 1 out of 5, and our probability of failure would be 4 out of 5. So our formula is n above R, so that's 10 above 7, times, then we do the probability of failure, probability of success. Remember, the number on the bottom, B for bottom, always goes with the B or the second number's exponent. So we put a 7 there and a 3 there. Because those two numbers, those two exponents have to add up to 10, or whatever our n is. So I'm going to move this over here so we can see it when we pull up the calculator. So we need to do 10 above 7. We get 120, and we multiply by 4 over 5 raised to the third times 1 over 5 raised to the seventh. And we get a rather tiny number. So let's see, that e to the negative 4 means times 10 to the negative 4. So I'm going to write this as a decimal first. We're going to have 0.000786. Or that would be 0.0786%. So it's a very, very tiny percent, like just under 8/100ths of a percent. So very small chance of this happening randomly. Alright, let's move on to the last question. Last example. At an intersection, the light is red for 45 seconds, yellow for 10 seconds, and green for 30 seconds. Find the probability that 3 out of the next 8 cars are caught by the red light. And we'll assume that if it's yellow, they're able to go through. So in other words, what's the odds that when they come to the light, it is red? Okay, so the number of trials in this case would be 8. That's the total number of cars. The number of successes we're shooting for is 3. Because in this case, we're defining success as caught by the red light. Because that's what we're wanting to know, how many are caught by the red light. And let's see, we need to figure out the probability of success. Okay, well, to figure that out, we need to know what we're aiming for. Well, we're aiming for the light to be red, and that happens for 45 seconds. And we need to do 45 out of the total amount of time for one cycle for the light. So if you add 45 plus 10 plus 30, you get 85. So your probability of success is 45 out of 85, because the light is 45 seconds red out of the total cycle, which is 85 seconds. And then Q is the probability of failure, so that would be what's left over. So that would be 40 out of 85. Now you can actually reduce these fractions if you want. I believe it would reduce to 9 over 17 and 8 over 17. As far as solving this, it doesn't matter. If you ever end up with a final answer, you should certainly reduce, but since this is just helping us get the final answer, it's not really a big deal. So we will do n above r, so that will be 8 above 3, and we'll do failure first, so 8 over 17, and then 9 over 17. So remember, the bottom number, in this case 3, becomes the exponent for the b, that's the second number. And then we need to add up to 8, so we make the other exponent of 5. Okay, so 8, choose 3, so 8, math, probability, 3. We get 56. We multiply that by 8 over 17. And back up and put parentheses around that. Sorry about that. 8 over 17 raised to the 5th times 9 over 17 raised to the 3rd. And we get a 19.1% chance. So this is something that's a little more likely than the first two we looked at. This is 0.19 for the probability, or 19%. So I'm going to say the answer is 19.17%. Alright, so that should cover it for binomial probability. This is not actually covered in our textbook, so I had to give out a worksheet. This is the homework on the worksheet I assigned at this particular time, but any problems on that worksheet would be good practice for this topic.